Welcome back to, let's see, I think this is probably installment 5, might be 6, depending on how I order these, but I pivoted to the fuselage since we're done with most of the flight control surfaces here. And what we're gonna do is I'm gonna lay up some fiberglass parts here. Very easy to do. I'm gonna show you my technique. But basically what I'm going to do here is I'm going to lay up some doors. This will be access for my switches and air. And then this will be an intercooler exhaust door. It's called the doghouse on a P-51. That will actually open and close with throttle movement. So what I'm going to do first is start off by monocoating some clear monocoat right over the top of the surface that I plan to lay up with fiberglass, and I'll show you how I go through that process. All right, we've got the monocoat applied. What I'm going to do next is going to use this a product called Partall. It's paste number 2. We're going to rub this in to the surface of the monocoat and then buff it out just to make sure that we've got a nice surface on the monocoat that will allow the part, once it's cured, to release and pop off. Okay, now that we've got about 3 coats of wax on there, you apply it, you let it dry to a haze, you buff it off. You do that 3 times, we should have plenty on there to keep the layup from sticking. Now what I do is I take a Sharpie, well this is a Milwaukee ink saw, and I will go over these lines with this Sharpie to identify the border. Now the cool thing about this is that ink that I lay down with this marker will be drawn up into the resin. And so I will have an idea as to where to make my initial cuts. Works out really, really slick. It may bleed a little bit, but it gives you a pretty close idea, because you want to make sure that, you know, especially when you're dealing with curves and different shapes, that it, you know, the position is going to be where you want it to be once you pull the part up. It doesn't have to be exact, just somewhere in the ballpark. Once we've done that, we'll mix up some, well, we'll cut all the fiberglass that I'm going to use to lay down. I'll talk over that, about that in the next step. Cool. So now that that's done, we'll move on to the next. Okay, so getting ready now that we've got the fiberglass cut. What I'm using here is, this is just my personal preference, but I've got some 2.5 ounce cloth here that'll lay on the first layer. Then I'll fill that with 3 9 ounce layers. And then I'll finish it on the outer surface with another 2.5 ounce layer. It's easier to get a nice smooth finish here. Again, I am no expert at laying up composites, but this method just works for me, and so that's what I end up doing. Again, just 2.5 ounce layers. This is a very tight weave cloth that will show up very nice and smooth once everything cures and you sand it. And then 3 9 ounce layers as well. Now, my personal preference for something like this, I've used epoxy, West Systems. I've also used probably mostly fiberglass resin, just this stuff, this Bondo product that you can get at Walmart. This works really, really well too. The downside to this product is it is a bit stinky, but it does sand very easily, a lot easier than epoxy does. And I don't know, it just works for me. So I'm gonna get this mixed up, and we'll start applying this and let this lay up and cure. All right. So I just mixed up 1 ounce, definitely more than I need. And we'll just apply this first layer right over the cloth, making sure that we get it probably at least a ½ inch beyond the lines that I have marked here. A good liberal coat of resin here to start with. So that should do that section there. We'll come down to the doghouse. I really have a lot of respect for, the experts in this field. I've watched Pete Goldsmith work his magic on, his latest project, the T-38 quarter scale that he has been producing. And I'm just in awe. Phil Clark over in the UK. This is nothing in comparison. It just doesn't compare. As far as mold making and all that stuff is concerned, sandwiching and vacuum bagging and all that. I'm just going to fill this in here too. We'll just make it easier for that second layer of cloth to stick. You just want this to lay down nice and flat. Make sure that it's totally soaked with resin. You don't have any wrinkles. So that's looking pretty good. So now we'll put our first layer of 9-ounce cloth down, and we'll just kind of repeat the process. And I squeegee this on down just to force as much of the resin that's laying on top into the weave. Making sure that we don't have any wrinkles or voids, any air pockets or anything of that nature. Once that's down, you can see the ink from the Sharpie marker is kind of bleeding a little bit. But again, it still gives us a kind of a good idea as to where it goes. With this polyester resin, this stuff, you have about 30 minutes of working time before it starts to go to pot, and you'll feel it start warming up in the cup when it does. And once you start feeling that, then it's time to stop, because you want to make sure you're laying this down nice and wet and where that catalyst hasn't had a chance to harden the resin. But it's kind of fun to do. I mean, it's not hard. I know the first time I tried this, it's probably, gosh, almost 15 years ago when I laid up the gear doors for my Top Flight P-47 kit that I did. And when that was all over with, I'm like, well, that wasn't too bad. Some people may think that, well, that's too thick of glass that you're using to make those panels. And for one, they're small parts. Yes, it's after the CG. But I want these things, I don't want them to bend, when we're using, particularly, not so much with the doghouse, but at least with this area here, with this access for my radio switches, something that I'm going to be using, opening and closing all the time. I like to have that extra rigidity. We fly in some pretty hot climates, us Warbird guys, when we get together. And if you make them too thick, they're gonna bend. They'll still hold their shape, but I don't know, I like something a little more solid. That's just me. Now this part will be ready to pop off in a few hours. I think it's probably best to leave it, you know, cure overnight. I've got to leave for work here in a couple of hours, so I won't be back until late tomorrow night, and then we're going on vacation. So in any event, it'll pop right off, and then I can use cutting this stuff is another task. You can use a scroll saw. I've used that before. You're going to go through a few blades, just cutting these parts out. It does dull them rapidly. Anything that's a diamond bit works really, really well. I have these Bosch blades in my Rockwell unit that works really well with cutting these things too. And that's what I'll use to cut these out with. All right, one more layer of the 9-ounce cloth, and then we'll put the final layer on. Got some fuzz here. I'd like to see how the manufacturing process with this fiberglass cloth is done. I've always been kind of curious about that. As you know, this stuff just frays and it gets everywhere. The fiberglass that I have here, I use Fiberglass. I've had great success with their products. The most popular, I've got a 0.56 ounce cloth that I use for glassing structures, and I've also got, you know, for fuselages and wings and such. I've also got an 1.5 ounce cloth too. It's a very tight weave silane finish that I use as well if I really want to strengthen up some lightweight balsa and that kind of a thing. But for the most part, that 0.56 is what I like to use for most applications. So now we've got the final 2.5 ounce layer that we'll just kind of squeeze into position here, and we'll put a fairly heavy coat on this just to make sure that we've got some room for sanding. And when I sand this initially, I'm just going to sand this actually in place before I actually pull the part off. Since it is a curved structure, it's just easier to do it that way, I found. When I come back after vacation, we'll go through those steps. Again, a pretty thick layer here, just to not only just fill the weave. And the experts out there may say, well, you know, that top layer is gonna lift up a little bit, and it may. I've actually had great experience with it not lifting. You don't want to put too heavy a coat on here. You can see I'll use up almost this whole 1 ounce pot of resin. It's still nice and fluid yet. It hasn't started to heat up. We've got just about the right amount of working time here. Need a little bit more down here. Cool. So when this is done, this piece will be about 1/16, or these parts rather, will be about 1/16 inch thick. So again, not overly thick, but when you sandwich these together like this, it actually produces a pretty strong part. Cool. I'll just use the rest of this just to kind of fill in the outer boundaries here. Just makes it easier to cut them out. This is looking pretty good. Cool. So that should do it for the layup. We'll just let this cure, and we'll come back and sand and then pop this part off. Sticky stuff. We'll see you in the next one. Well, hey everybody, I'm back from work. This is nice and cured up. I know I mentioned before I was just going to stand this in position. I don't have the patience for that right now. We're getting ready to go on vacation. So I'm going to pop this off and make sure we've got a good separation here. Just kind of go from this corner and just gently lift from the corners. Get those started. There we go. We have a part. Popped off real nicely. That release compound did its job. So just have to sand that up real good, cut the lines out. As you can see, they transferred quite nicely. So I've got something to use as cut lines just to get somewhere in the neighborhood, and then we can fine tune that. So more to come on that. Thanks. Okay, we got the part all sanded here. What I did is just kind of went over these lines again with a thin Sharpie, because I'm going to be cutting it with the outside down. And I'll be using my Rockwell saw. I use this a lot. It works really good. And this is the blade I use, if you can see that. This is a Bosch diamond blade. It's used for cutting basically tile. I use it for fiberglass, and G10 works really well with that. I've had this for a very long time, and I've cut a ton of glass with it, and it's still, although you can see the paint wore off, the teeth are still extremely sharp, and it'll go through this no problem. Hey everyone, welcome back. Been a little bit of a busy time here with vacation and work and stuff, but I thought I'd continue on with our fiberglass layup and where we're at now. I'll give you a peek here. All right, so I've went ahead and cut this radio or service hatch to fit the opening here. And basically what we have is this installation here. So I used the Robart large bomb door hinges. I just happen to have some of those. They work out very good for a hatch such as this because it opens kind of like a bomb door would. There's a rare earth neodymium magnet here, and of course the receiver is down here. But this, since it was molded to the fuselage, as you can see, fits perfectly. So pretty happy with that. Obviously there's going to be some filling and such to go along with that. I did lay up this part as well to serve as this, but this is the one I built from my full-scale build. One of the parts that I cannibalized, one of many parts that I cannibalized, and fit this and modified the fuselage for the doghouse. This is basically the turbo intercooler exhaust. So the airflow that goes through the scoop right here. Obviously this is closed off, it's just faux. Goes through that radiator, and the exhaust air comes out the back. Now, in the full scale, what this has done, it's thermostatically controlled, so it will open and close, it'll modulate to maintain a consistent temperature of the fluid that's used to cool that Merlin engine. And so what I did was, I don't know if you can see it, but right down in there, there's a Sullivan ball link and a carbon rod, kind of overkill, and a big control horn that's mated to that. And then I went ahead and installed a little servo here, an HS85 metal gear servo. It doesn't take much power to open and close that. And if you look, and you can kind of see all the way through there. Anyway, so I went ahead and mixed this using a free mix, and drew up a curve so that with throttle stick movement, that door will open and close. So at idle, it's fully open, meaning that there's just not a lot of airflow through there. So this opens up to allow more airflow to actually escape and exhaust aft, thereby providing more cooling to the coolant. As I increase the throttle, again, it's on a curve, that last half gets a lot of movement. And when you're at full throttle, it's fully closed like this. And typically, in my observations at air shows, that's kind of what I end up seeing. So just did that to replicate that a little bit. Kind of happy with that. I ended up cutting out this entire section here, and then I filled this in with some 3/16 balsa. And of course you can see I've got the tail wheel mounted here as well. Those holes are to gain access to the screws that will secure the top portion, or in this case the bottom portion, of this tail wheel retract. And of course there's 2 more screws down there that do that. It'll be a pull-pull operation for the tail wheel, and the doors will be held shut by rubber bands as per the plan with Top Flight. And these little arms right here will keep them open when the gear is down. When the gear retracts, those arms go out of the way, and the rubber band tension will close the gear doors. So back to this hatch and the layup that I have set up here. Worked out pretty well. There's no real good place on a P-51 to have an access hatch that matches an absolute, an actual panel on the aircraft. And so I just chose to, what I did on my first full kit build, is just to put this down here in the keel. And I think that works out pretty well. One switch, I'm just going with a single battery in this one. It'll be a 4,000 amp life battery, and then one 2200 life battery for the ignition. And these little guys here, you can see here, these will accommodate an EC3 connector, and then the balance port too. I got these from Scale Engines. I think it was Scale RC Engines. Anyway, they're kind of entering the scene, or have been on the scene in the RC landscape with printed radial engines, and of course they've expanded their product line. But these are pretty handy. So they'll capture both the balance connection and then the associated EC3 plug for charging. So that's fairly convenient, not having to take the wing off and all of that, or having wires dangling around. So I'm pretty happy with that. Obviously the air fill port, and that's just a standard Robart pressure gauge there. This whole thing is modular. It's removable. You can see there's 4 screws there, and that'll gain access down in there if I ever need to replace a switch or do maintenance or anything, or swap out batteries, whatever the case may be. So that worked out pretty well. Another thing I did here throughout the course of this is I actually built up the structure that captures the wing mounting plate. There have been some failures in the past with this. I don't know so much on the P-51, but definitely the P-47 where this actually ripped out. So I went ahead and fixed that problem by cutting out some 1/8 inch, actually 3 different pieces of 1/8 inch ply to build this out, make sure that it's mated to this fuselage structure, the sides, so that that won't happen. And it's in there very, very solid. That's all air epoxied in place. Tank's mounted, the throttle servo is there. Tank comes out with these 2 screws here and the whole thing will come out. It's all modular. I've got the ignition mounted in there as well. I printed off a ignition mount off of RC Scale Builder. Again, JP Warbirds, Jerry Precop was kind enough to place that among many other of his designs on the scale repository, or the 3D repository on RC Scale Builder. So great resource there for sure. As far as what's next, you can see here I haven't really talked about this much, but this is the cowling that I'm going with. My friend Leo Spichala produced these for a lot of years, and he tells me that this is the last one that he's produced. So in any event, if you know Leo, maybe you can talk him into it. I don't know. But in any event, these are really great cowls. And what they do is they're designed specifically for the ARF. So this cutout right here is actually already in the mold. And so that works out really, really well. Right now, the cowling is just temporarily mounted. It's just screwed into place. It will be permanently mounted. And then this portion here, as you can see, these screws in the scale location, will actually be removed for engine maintenance, engine removal, whatever the case may be. And there's actually pretty decent access in there. It is pretty tight. Engine's all mounted. We've got a very nice, consistent 1/16 inch gap between the spinner backplate and the cowling. I had to rotate the engine slightly to make it all neatly fit inside that cowling without cutting anything else out. The muffler was the biggest thing that was in the way, so I had to rotate it about 10 degrees. As you can see, the exhaust stacks are not aligned, but that's okay. So that should work out pretty well. So next steps will be to permanently mount the cowling. That'll be high sol or air epoxied into place. And then there'll be some filling and stuff that'll have to be done here as well. I'll have to build this out a little bit. There's about a 1/32 inch lip. I could probably just sand this down, but I think what I'm going to do is just kind of build it up and lay it in place like that. So that should work out awesome. So I'm thinking I'm going to have enough cooling here. This is an EME 55 with a slim fitting pit style muffler. You can kind of see it there. I actually had to grind down a little bit of that muffler again just to kind of make everything fit. But with the airflow coming through this inlet here, the airflow going over to the head that is exposed, which isn't a ton, and then of course the all these holes through the oil cooler and a slight margin around each exhaust stack. I think we'll have enough. I'm also going to open up a hole inside the mounting block for the engine that will actually carry some airflow through the fuselage as well, and that will escape for sure through here. So we shouldn't have any positive pressure that will be built up inside the fuselage. So that should work out awesome. So let's see what else. I did mount the wing already. You can see it sitting here. So that's all mounted up. We've got obviously the gear extended here. You can see some of the wheel well detail. It's a little bit messy. I went ahead and built up a transition piece from the leading edge to match the contour of the cowling, or excuse me, of the fuselage itself. What Top Flight gives you on the ARF is this fiberglass piece. I chose to just build mine up with wood. I prefer that anyway. That will, once I finish sand it and do a little bit of filling, that should work out pretty nicely. So anyway, had the chance to get out and do some flying here recently, mainly with the F4F Wildcat. There's a scale competition coming up here at my local field at Silver Hills RC at the end of May. So I've got 9 flights on the Wildcat so far, and I tell you, it just keeps getting better and better. It is all dialed in. I'm still playing with the engine mixture. We're still a little bit on the rich side, but that should be taken care of here with this next adjustment. So it's flying really, really well. I look forward to actually putting it into competition, so that should be good. I need to get these other airplanes out and flying here this spring as well. Like the ME-109, that hasn't flown since I repaired it this past fall. So anyway, that's about it for now. Stay tuned for the next one. I'll go over some probably fiberglass prep and probably some engine installation stuff in that video as well. So that should be fairly informative if you're interested in that. Thanks again for watching. Really appreciate it. If you got any comments, leave them down below. I'll answer them as best I can. Take care.